Okay, special products. We have seen special products in one of the previous videos. A special product is of the form a plus b squared is equal to a squared plus b squared plus 2ab. Now, if we change that a and b to say x and a number as an example, if I had x plus 2 squared, a is x and b is 2, and we have a squared, which is x squared. 2 squared would be b squared. 2 times x times 2, which will give us x squared plus 4 plus 4x. So we have x squared plus 4x plus 4. Now you can see just by replacing the a and b by x and 2, we sort of come up with a trinomial. So the purpose of knowing special products is that some of the trinomials can be written as a special product. In other words, in a short form, a plus b squared. And if I can write it as a plus b whole squared, then it simply means a plus b times a plus b. And that is going to make things easy for us. So that is the first special product that we must know. The second special product is something that we have seen before. A minus b squared is a squared minus 2ab plus b squared. The next special product is a squared minus b squared that simply is a plus b multiplied by a minus b. Pay close attention to the left-hand side. The right-hand side expressions are trinomials. The left-hand side are simply the factored versions of the trinomial. So all we are trying to do is to factor a trinomial using a special product. So a minus b whole squared corresponds to the trinomial on the right. A plus b times a minus b is simply the trinomial a squared minus b squared. Even though it's a binomial, I'm calling it a trinomial for the sake of it. So probably I should say slash polynomial. A plus b whole cubed, which is simply a plus b multiplied to itself 3 times, would simply be equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. These are time-tested and proven identities. You can verify this too. They're very straightforward to verify. A minus b whole cubed would simply be a cubed minus 3a squared b plus 3ab squared minus b cubed. The special products number 6 and number 7 are quite important because on the left-hand side, on the right-hand side, you see something very simple. All you're saying is a cubed minus b cubed. But on the right-hand side, its factored form is quite interesting and lengthy. It's a minus b multiplied by a squared plus ab plus b squared. I'm running out of space here. Likewise, a plus b multiplied by a squared minus ab plus b squared would be equal to a cubed plus b cubed. So pay close attention to the signs, and there is sort of a synchrony between those signs. If we have a cubed minus b cubed, the first factor will have a minus and the middle coefficient would have a plus. If it is a cubed plus b cubed, the first factor would have a plus in between and the middle coefficient ab would have a minus. So what is the objective or the use? So if a polynomial is a special product, then we use the above identities to factor. And that's it. So here we have a polynomial, but how do we recognize if it fits one of the special products? So the key here is to have, this is a second degree polynomial. So we need to either look for a plus b whole squared, a minus b whole squared, or a squared minus b squared. So what are the key things to look for? First, it is the constant coefficient. Is that a perfect square? It is a perfect square. In other words, we have 3 squared equals 9. And obviously, x squared is a perfect square. So what I'm going to say here is A is x, and B is 3. So we have a squared there and b squared there. And if that middle coefficient equals 2 times a times b, Then we can use the identity a squared plus 2ab plus b squared equals a plus b whole squared. Okay, let's see if the middle coefficient equals 2 times a times b. So 6 is 2 times a times b. So 2, b is 3, a is x. So if I multiply all of them, I end up getting 6x. So I should simply say middle term rather than middle coefficient. So it seems like our trinomial follows the pattern a squared plus 2ab plus b squared, which means we can use this identity right there. So we can write x squared plus 6x plus 9 as a is x, b is 3, x plus 3 whole squared, which is x plus 3 multiplied by x plus 3.
Can you just put that back down for just 1 sec, Dr. BG?
So, how do we identify that this trinomial would fit into a category of the 3 special products we have? Same question to ask, well, is the last coefficient or the last term a perfect square? So that term is actually 5 squared. So that gives me an idea that b is probably 5. I mean, we're just hypothesizing and verifying if everything falls in place. So as of now, b is 5. And I'm going to say a to be x, so x squared is simply a squared. So b is 5, a is x. And if the middle term equals to 2ab, then use a squared plus 2ab plus b squared equals a plus b whole squared. Now this is, I did it this way so that you can see something. You look at the trinomial, ask the same question, okay, is the last term a perfect squared? I'll call the first term as a squared, but there is a key difference between the previous problem and this one. The middle coefficient has a, excuse me, the middle coefficient or the middle term has a negative sign in it. So it is unfair for us to compare this trinomial to the special product that I just wrote. So we have to use the other special product, which is a squared minus 2ab minus plus b squared equals a minus b whole squared. So the question now is, if the middle term still equals 2ab, but with a negative sign in the middle. So what is the middle term? The middle term is 10x. So 2ab is what we need. So 2a is x, b is 5, 5 times 2 times x is 10x. So it checks out. We have a squared minus 2ab plus b squared. Therefore, x squared minus 10x plus 25 would equal to a, which is x, minus b, it's 5 squared. We have x minus 5 multiplied by x minus 5. So that is the factored version. A key thing to note here is we've got to be very careful in the order of terms. we always start with the highest power of x, and we go down. So the x squared term must be the first term, the x term must be the second, and the constant term must be the third. So you look at this trinomial and you look at the third term, and it is a perfect squared. 1 squared is 1. So I'm going to say that b is 1. Now, what should a be? What should I call a? In the previous cases, things were just easy. It was just x squared. Now here I have 25x squared. So in order to identify a, you should ask yourself if the coefficient that I've multiplied here is a perfect square. Naturally, 25 is a perfect square. So I have a perfect square multiplied by x squared. So I can raise it to the common power of 2. So I'm going to say a is simply 5x. If a is 5x, would that term be a squared? A squared simply means a times a, so I have 5x times 5x, which is 25x squared. Checks out. So if a is 5x and b is 1, the middle term has to be 2ab. Let us see if we get 2ab. For us to have 2ab, we need 2 multiplied by the 5x that I assumed, multiplied by the 1, which is b. And if I multiply all of those, I get 10x. So that checks out too. So the given trinomial satisfies a squared plus 2ab plus b squared. Therefore, I could write 25x squared plus 10x plus 1 as a, which is 5x, plus b, which is 1, squared, which is the same as 5x plus 1 times 5x plus 1. You can always verify if the factoring that you did is correct or not by foiling, but you should just build the confidence to a point where you don't have to even check your work. Then that comes with practice. So here we have this expression 2x squared plus 28x plus 98. 2 is common amongst all 3 terms. So I'm going to pull that out first. So x squared, 14x plus 49. Now I can ask the question, well, is 49 a perfect square? It is. So if b squared is 49, then b is simply 7. And if a squared is x squared, a is simply x. All I need now is the middle term to be 2ab. So we have 2 times a times b, which is 2x multiplied by 17. So it checks out. Which would imply we could write 2x squared plus 28x plus 98 as 2 multiplied by a plus b squared. A is x, b is 7 squared. Therefore, the answer is 2 multiplied by x plus 7 whole squared. So we have 16x squared minus 56xy plus 49y squared. And it looks pretty scary, but what we can't see is that 16 is a perfect squared, 49 is a perfect squared, and of course I have x squared and y squared, which are perfect squares in and of themselves. So how could I write 16x squared? We can write 16x squared as 4x raised to the power of 2. And we could also write 49y squared as 7y raised to the power of 2. I'm simply using the properties of exponents. So that gives me an idea that A is 4x and B is 7y. So I'm going to say A is 4x and B is 7y. So that becomes A squared, that becomes B squared. Do we get 2AB there? What is 2AB? 2 times 4x times 7y. 2 times 4 times 8, 2 times 4 is 8, and 8 times 7 is 56. Checks out. And x times y is xy. Checks out. So the middle term is in fact 2AB. But notice that there is a minus, so we have to use a minus b whole squared. So 16x squared minus 56xy plus 49y squared is simply a, which is 4x, minus b, 7y squared. It is the same as 4x minus 7y multiplied by 4x minus 7y. So this might look like a scary polynomial, but the first thing to note here is we have y cubed, y cubed, y cubed. And y cubed is in common. So the very first step has to be to pull out that y cubed. And if I pull y cubed out, I would have 4x squared minus 4x plus 1. And now we have a nice little polynomial inside the square bracket. And I could write that 4x squared as 2x whole squared minus 4x plus 1 squared. So that sort of tells me A is 2x and, but 2b, 2x, and b is 1. So I've got a squared, I've got b squared. The question now is that 2ab? So we have 2 times a, which is 2x, b is 1. 2 times 2x times 1 is, in fact, 4x. Checks out. So I can write whatever term that whatever polynomial that I see inside the square bracket as a minus b whole squared, because I have a negative there. So 2x minus 1 squared. So the answer is y cubed multiplied by 2x minus 1 squared. So the next one is an interesting case, but I've seen students take it and make it way too complicated by foiling. The way to approach this problem is to recognize that there are only two terms, it is a binomial, and the next question to ask is, are they perfect squares? Anything squared is a perfect squared. So you could have y plus 2 squared, y plus 3 squared, doesn't matter. And is 49 a perfect squared? Yes, it is. So if I call A to be plus 2, I would have y plus 2 whole squared. And B is simply 7 then b squared would be 49. But also write it as y plus 2 squared minus 7 squared. You can see it better. Now, what do we know about the special product that gives us a squared minus b squared? So recall a squared minus b squared is simply a plus b multiplied by a minus b. We have a is y plus 2, b is 7, and same y plus 2, b is 7, so minus 7, which would give us y plus 9 multiplied by y minus 5. So even though the original problem looked kind of scary, in reality, that simply equals to y plus 9 times y minus 5. So y plus 2 whole squared minus 49 is equal to y plus 9 times y minus 5. So the first term is a perfect square, so I could simply write it as a squared, which would mean a is 3x plus 5. Is 25 a perfect square? Yes, so 5 squared. So b would be 5, and we know a squared minus b squared is a plus b multiplied by a minus b. That is an identity. So I can write 3x plus y squared minus 25 equal to a, which is 3x plus 5 plus b multiplied by 3x plus y minus 5. So a plus b multiplied by a minus b. And, clearly you can't simplify this any further. In the last problem, things got simplified. Here, we cannot go any further. So now we have cube terms, and we have to factor. We have x cubed plus 27. The moment we see cubes and we have only two terms, you first pay attention to the sign in the middle. Then you have to pick one of two identities. It's either number 6 or number 7. Since it is plus, we're going to pick identity number 7. So x cubed plus 27 would mean perhaps I could write it as a cubed plus b cubed. And I know the factored version is a plus b multiplied by a squared minus ab plus b squared. Now, is 27 a perfect cubed? X cubed is a perfect cubed. 3 times 3 times 3 is 27. So a is simply x and b is 3. So I can go back here. Since it falls into the pattern of a cubed plus b cubed, we can write x cubed plus 27 as a plus b multiplied by a squared minus ab plus b squared, which is 3 squared, and 3 squared is simply 9. So we have x plus 3 times x squared minus 3x plus 9. I've seen folks foil this and write it as a complicated cubic polynomial. Keep in mind that defeats the purpose. There is no need to go back and foil it because you'd end up getting x cubed plus 27. We want it in a factored form, and that is why we are doing this entire process and getting to know of special products. So first thing, I don't know if they made this intentionally. Okay, first thing to do is to pull out a common factor. Now, what is a common factor between 250 and 16? The 250 is a multiple of 5. So we could write 250 as 2 times 125. I can reduce it further more, but I'm not going to. I could write 16 as 2 times 8. So there is no common factor between 125 and 8, because 125 is divisible by 5 and 8 by 2. So they don't share anything in common. So the greatest common factor is simply 2. If you don't pull the 2 out in this problem, you're very 95% likely that you're going to be stuck. So if we pull 2 out, I'm left with 125 y cubed minus 8 x cubed. The next question is to ask, well, could we write 125 as the power or third power of some number? We absolutely can. Recall 5 cubed is 125. 5 times 5 times 5 is 125, which is simply 5 cubed. 8 is simply 2 cubed. So 2 times 2 times 2 is 8. So I could write 125 as 5 cubed multiplied by y cubed, 8 as 2 cubed multiplied by x cubed. If we use the properties of exponents, bases are different, identical powers, so I combine the bases and raise it to the common power. And bases are different, powers are identical, combine the bases, raise it to the common power. So now it seems like that would be A and that would be B. So say A is 5y and B is 2x. And we know A cubed minus B cubed is A minus B multiplied by A squared plus AB plus B squared. We could write 250 y cubed minus 16x cubed as 2 multiplied by whatever we have here, which is simply A cubed minus B cubed. So A minus B, 5y minus 2x, multiplied by A squared, 5y squared is simply 125y squared, but I don't want to skip a step. So I'm just going to write them individually, multiplied or plus 5y multiplied by 2x, which is b, plus 2x squared. I'm just plugging in the a and b we identified. So now we would have 2 times 5y minus 2x multiplied by 5y squared is 25y squared. 5 times 5y times 2x is simply 10xy, and 2x whole squared is 4x squared. And that would be the final factored answer. So the first term is easy. It's a perfect cubed, so I can simply call it as a cube. The second, though, we have to realize if 125 is in fact a perfect cube. From the previous problem, it is. So since 125 is 5 cubed, I could write it as 5 cubed multiplied by q cubed, different bases, identical power, so 5q raised to the power of 3. So that would be b cubed. So we have a is p and b is 5q. There is a plus sign in the middle, so p cubed plus 125q cubed would equal to the a plus b for a cubed plus b cubed formula. So we have b, which is a, plus b multiplied by a squared, which is p squared, minus ab, p multiplied by 5q, plus b squared, which is 5q squared. So we have p plus 5q multiplied by p squared minus 5pq plus 25q squared. So here we have x cubed minus a, and that is x cubed is a perfect cube, so that's simply a cubed, minus 8 is also a perfect cubed, which is 2 cubed. So I'll call that b cubed, which tells us a is x and b is 2. And since there is a negative, we've got to use the a cubed minus b cubed special product. So x cubed minus 8 is simply a minus b, x minus 2, multiplied by a squared, which is x squared, plus ab, so 2 times x, plus b squared, which is 2 squared, we'll get 4. So that is the final answer.